This is our strange collision behavior program, which is going to illustrate some odd behavior we can get when we collide objects. And it's all due to the fact that our physics model, the way we detect and the way we detect collisions and behave when we have collisions, is really just a little bit simple for some circumstances. So let's take a look at what happens. I've drawn a box right there. I've got a circle right here. This circle is going to have an x velocity of 1, so I'm going to move it in a loop using an x velocity of 1, moving it over 1 pixel, and so on, until we collide with this box. And when the box is hit, which I detect with the collides method, I'm going to set the x velocity to -1, and I'll move it backwards. So let's take a look at what happens. Move over pixel, and so on, collide, x velocity is -1, and it moves backwards. So that's normal behavior. That's great. Now the next thing we're going to do is put the circle up here, and now we're going to move it down diagonally, and again we're going to move it 1 pixel at a time, but this time it's over 1 and down 1, over 1 and down 1. So we're moving it diagonally. It's going to collide about here, and then our behavior is going to be strange. So let's take a look at it. It'll go to here, and then it should bounce off that way, but it's not going to do that. Instead it's going to zigzag back and forth down this bar. So let's take a look at that. Now what's happening is it collides, so it jumps to the left, then it collides again, so it jumps to the right, then it collides again, it jumps to the left, and so on. It repeats colliding. It's in some sense inside this bar, colliding, moving, colliding, moving, colliding, moving, and eventually it drops out and it's no longer colliding, so the x velocity doesn't get changed. The overall result is because our object gets inside this bar, we say the x velocity is -1, so it jumps here. Now it's still inside the bar, it's still colliding with the bar, so the x velocity gets switched to 1, so it moves over to here. It's still inside the bar, the x velocity gets set to -1, goes to here, x velocity is 1, goes to here, -1 goes to here, and it wiggles back and forth down the bar. Now the truth is, we defined velocity and collisions, we've defined our velocity change with collisions correctly if we're hitting a vertical bar. If we're hitting on this side, or if we're hitting on this side. But when we're hitting on the top and coming at it diagonally, I need to change the y velocity, and my physics model just doesn't accommodate for that. In fact, it's a little bit difficult to do that. So mostly this program is about why that happens, and let's take a look at the example program. Basically, I set up a window, I made the box and the circle, and I set an x velocity, opened up the window. This much moves it right till it hits the box, moving over by 1 pixel, over by 1 pixel. Once we hit a collision, then I switch the x velocity, and I hopped out of that loop so that I can use another loop that says just move over 200 times, moving to the left. After that, I wait, and then I put the circle above and to the left. And now I run the same code as I had before, moving to the right. But because I'm going to hit on the top, because that circle is above and to the left, I'm going to hit on the top when I hit, and that means I'm going to be switching the x velocity, and I'll still be colliding, so I'll switch the x velocity again. I'll still be colliding, so I switch the x velocity again, and again I get this normal behavior. And then this odd behavior. Now there are ways we can program our way around this. I just want you to be aware that this kind of behavior can happen. We're not going to worry about it for things like our Pong game. Later on we might worry about it for more advanced games. That's it.